in this problem, Alice will be greedily calculating the longest increase in subsequence, that is LIS. So we'll be basically given two values, that is the size of the array and then difference value. So now we had to construct a permutation such that the difference between the actual LIS value, that is the longest increase in subsequence value, and then the value that is computed by Alice is having a difference of k. So if you are able to find that, then we have to print it. Otherwise, we'll be printing -1. Now, how to solve this problem? This is a very simple problem. So you just need to take some cases and do some trial and error runs. So let's say we have the value of n as 6, and then the difference that we want is, let's say it's equals to 4, right? So let's try to calculate, or let's try to form some case for all the values of k. So instead of taking the value of k, let's just try to calculate the values for all the case from 0 till 6, right? Now, if we want a zero difference, then we can just arrange all the elements in the ascending order, right? So we can, for the case of k equals to 0, I can just arrange all the elements in the ascending order. So the permutation will be having all the elements in the order as 1, 2, 3, 4, 5, and 6. The assumption that I'm making is that I always construct my pattern in such a way that the greedy LIS is always 1, no matter what the sequence that I take. So how can we make this possible? So if I always assume that the first element itself is the largest element possible, then the greedy LIS will always be 1, right? So after this, I'll be constructing according to the difference. So I want to make a difference of 1, right? So if you want to make a difference of 1, then the greedy LIS is already 1. So if the actual LIS is 2, then I can get a difference of 1. So what I'm trying to say is the greedy LIS is always 1, right? And then difference that I want is 1. So let me just name it as difference instead of k. So let it be as it is. The difference that I want is 1. Then the actual LIS should be k plus greedy LIS, right? So this is nothing but it's 2. So how can I construct a pattern such that it has an LIS of 2? So just arrange these elements in the descending order, and the first two elements should be in the ascending order. That is, it should be 1 and 2, and all these elements can be arranged in the descending order. So it could be something like this. So 6, 5, 4, 3, and then these two elements will be arranged in the ascending order. So the actual LIS will be 2, and then the greedy LIS will always be 1, as evident from the assumption that we have. Right, now let's try to construct the pattern for k equals to 2. So now the greedy LIS is fixed, so it should always be 6. So only if I put a 6 over here, the greedy LIS will be 6. So this is fixed. Now as k is equals to 2, so this will become 2. Hence my k plus greedy will be 3. Because I want 3 as the actual LIS, which means that I should be constructing the last 3 elements should be 1, 2, 3. So it will be descending till that particular point, and then it will be increasing from there. So 6, 5, 4, and then it will be 1, 2, and 3. Right. So this is how my pattern will be. Now, can I get a difference of 5? So if I want a difference of 5, then the actual LIS should be 6. Right. So if you want a difference of 5, then 5 plus 1 will be the actual LIS, which is 6. So if the actual LIS is 6, then it's nothing but all the elements are in the ascending order. That is this order. Only then the actual LIS will be 6. Now, in this case, even the greedy LIS will be 6. So, we won't be having any answer for the case of k equals to 5. So, it will be -1. And so, will be for the case of 6. So, in this case, I am just trying to get a difference of 6. So, not even get a difference of 5. Then how can I get a difference of 6? Hence, whenever we get a value of k, so if this k is equals to n minus 1, or if it's greater than or equals to n minus 1, then the answer will be -1. That is, I'll be printing -1 to the console. Otherwise, I'll be constructing the pattern such that I'll be having k plus 1 number of elements in the increasing order, that is ascending order, and then the rest of the elements in the descending order. So list of the elements in the descending order, and this should be in the first place. There is it should be first descending, and then it should be increasing. So this is how I can construct the answer to this problem. Now let's discuss how to implement the solution for this problem. So as discussed earlier, so we can only have solutions when the value of m is less than n minus 1. So if m is greater than n minus 1, then there will be no solutions. Otherwise, I'll be just constructing the pattern in this way. So till m minus 1, it will be reducing, and then from from 1 to m minus 1, it should be increasing. Right? And also there is another base case. So whenever n is 1, then if at all m is equal to 0, then the value will be 1. Otherwise, we won't be having any solution. So this is how we can implement the solution for this problem. So that's all about it for today. If you have any further queries or doubts, you may reach out to me in the comment section, or you may reach out to me in the social handles. And if you like this video, consider giving it a thumbs up, and do subscribe to the channel for getting the further notifications of the videos. And with that being said, it's me Sundar signing off, and goodbye. Keep coding.